Hello, and welcome to Beyond the Last Star. Wherever you are right now, whatever kind of day it has been, you made it here. And that is enough. Find a comfortable position. Let your body settle. If you can, turn the lights down low or off completely. Because tonight, we are not staying here. Tonight we are going somewhere most people never think to go. Past the last planet, past the edge of the sun's reach, into the deep and patient dark where the real universe begins. Before we leave though, drop a comment and tell me where in the world you are listening from right now and what time it is there. I read every single one. There is something I love about knowing that people from every corner of this small blue planet are drifting off to the same stars at the same moment. And if this is your first time here, welcome home. Hit subscribe so the next journey finds you. Now, are you ready? Let's go. The Milky Way is your home. Not just Earth, not just the solar system, but this entire vast spinning collection of stars and gas and ancient light that stretches across the sky on a clear dark night, like someone took a brush full of white paint and swept it slowly across a black canvas. You've seen it, maybe once, maybe many times, that pale river of glow arcing overhead when the city lights are far away. That soft light is not one thing. It is hundreds of billions of individual stars, each one burning, each one ancient, each one so far away that the light reaching your eyes tonight left its source before you were born, before your parents were born, before anyone alive today took their first breath. The Milky Way has been above you every single night of your life, patient and enormous and completely indifferent to your worries, turning slowly in the dark while you slept and woke and slept again. And tonight, as you close your eyes, it is still there, still turning, still carrying you along with it, gently, without effort, without asking anything of you at all. There is something deeply settling about that. Something so old and so large has no interest in your to-do list. It simply continues, and so can you. Our galaxy is shaped like a flattened spiral, a great disk of stars with long curving arms that wind slowly outward from a bright centre, like a slow whirlpool seen from above, or the surface of still water after something large has passed through it. If you could somehow rise above it and look down from far away, it would look like a pinwheel, softly glowing, turning almost imperceptibly. But here is something most people never think about. The arms are not solid. They are more like waves moving through water. Stars drift into them, brighten, and drift out again. The spiral shape is a pattern, not a wall. It is the universe making something beautiful out of pure motion, out of the simple mathematics of gravity and time. Our own solar system sits in one of these arms, tucked quietly between two of the larger spirals, about 2/3 of the way out from the centre. Not the most dramatic address, not the centre of things. A quiet neighbourhood, relatively calm, relatively safe. The kind of place where a small star can burn steadily for billions of years without too much drama. And in that calm, on one small planet around that small steady star, something looked up and started asking questions. That small act of looking up is one of the most remarkable things that has ever happened in this corner of the galaxy. The Milky Way contains somewhere between 200 billion and 400 billion stars. That range, a margin of 200 billion, is itself one of the most astonishing numbers in science. 200 billion stars we're not entirely certain are there simply because the galaxy is so large and so layered with dust and distance that counting becomes more like poetry than math. If you tried to count to just 1 billion, saying one number every single second without stopping, without sleeping, without pausing even once, it would take you over 31 years. To reach 400 billion at that same pace would take more than 12,000 years. You would have started counting before the first cities were built on Earth. You would still be going, every second of every day for longer than all of recorded human history, and still not finished. And each of those stars is a sun. Many are larger than ours. Most are older. Most are likely surrounded by planets of their own. The number is too large to hold in the mind all at once. And that is exactly the point. You were not built to hold numbers this large. You were built to feel the edges of them, the way you feel the edges of sleep. Not fully, not all at once, but gently, as something vast draws you slowly in. Our solar system travels around the centre of the Milky Way at roughly 828,000 kilometers per hour. That is not a typo. 828,000 kilometers every hour, which works out to about 230 kilometers every single second. At that speed, you could travel from one side of Earth to the other in less than a minute. And yet at this extraordinary speed, it still takes approximately 225 million years to complete one full orbit around the galactic centre. Scientists call this a cosmic year, or a galactic year. In all of human history, every empire, every discovery, every war, every quiet ordinary Tuesday, we have not even moved a measurable fraction of a single degree along this enormous path. The dinosaurs appeared and disappeared in less than one galactic year. Everything that has ever happened in human civilization fits into a period so brief that the galaxy barely noticed. You have never felt this motion. There is no wind against your face, no vibration, no sense of speed. The universe travels in perfect silence, and yet right now, lying completely still, you're aboard something that has been in continuous flight for longer than the Earth has existed. You're moving, you're always moving, and still you can rest. At the very centre of the Milky Way, hidden behind thick curtains of gas and dust that block visible light entirely, there is a supermassive black hole. It is called Sagittarius A star, and it has a mass roughly 4 million times greater than our Sun. 4 million suns worth of matter compressed into a space smaller than our entire solar system. We cannot see it directly. The dust between here and the galactic centre is so thick and so deep that no optical telescope has ever glimpsed it with visible light. But radio waves pass through dust. Infrared light passes through dust. And using these invisible forms of radiation, astronomers have mapped the movement of stars near the centre. Stars that swing around the black hole in tight, fast, breathtaking orbits, completing full loops in just a few years, moving at speeds that dwarf anything else in the known galaxy. Watching those stars move is how scientists confirmed what the mathematics had long whispered, that something massive beyond imagination sits in perfect silence at the heart of our galaxy, pulling everything slowly toward it, holding the whole spinning structure together. It does not threaten us. 26,000 light-years of distance keeps us entirely safe. But it is there, always there. The quiet centre around which all of this, all of us, slowly turns. The light from the centre of the Milky Way that you might detect tonight left its source approximately 26,000 years ago. 26,000 years ago. Human beings were painting animals on cave walls in southern France, pressing their hands against stone and blowing pigment around their fingers to say something that has lasted. They were crossing land bridges into continents that had never known a human footstep. They were watching the same stars you see tonight and giving them names that no one living remembers anymore. And in that exact moment, the light now arriving at telescopes was just beginning its journey, setting out from the galactic centre into the long dark, travelling at the speed of light through gas clouds and empty space and the slow breath of the galaxy, taking 26,000 years to cross that distance and arrive here, now, at this particular moment in history. Everything you see in the night sky is old. Every point of light is a message from the past. The universe does not deliver its news in real time. It sends it slowly, across incomprehensible distances, and by the time it arrives, the source has already moved on, already changed, already become something different from what the light shows. When you look at the sky, you are reading letters written long before you were born. The Milky Way belongs to a small neighbourhood of galaxies called the Local Group. It contains more than 50 individual galaxies of different sizes, vast spirals, small irregular clouds of stars, faint dwarf galaxies that are barely more than a loose collection of ancient suns. The two largest members of our group are the Milky Way and the Andromeda Galaxy, which faces us from a distance of about 2.5 million light-years. On the very darkest nights, far from any city or town, Andromeda is visible to the naked eye. A small smudge of faint light, easily missed, easily confused for a dim cloud. But that smudge contains 1 trillion stars, 1 trillion suns, all burning, most of them circled by planets, the whole thing turning slowly in the dark at a distance so vast that even light takes 2.5 million years to cross it. And yet, on a clear night, you can hold your thumb up and cover it entirely. Beneath your thumb, invisible and impossibly remote, is 1 trillion fires. That is what the dark contains. That is what the universe hides inside its quiet. Our galaxy is approximately 10 billion years old. It formed roughly 5 billion years before Earth even existed, beginning as a loose, enormous cloud of hydrogen gas slowly collapsing under its own gravity, heating as it fell inward until the first stars began to ignite in the dark. Those first stars were enormous and violent and brief, burning through their hydrogen in only a few million years before exploding as supernovae, scattering the heavier elements they had forged deep in their cores out into space: carbon, oxygen, iron, silicon, the very materials that would one day become planets and oceans and everything alive. The Milky Way is built from the wreckage of those ancient explosions. Everything you are made of passed through stars that no longer exist. The disk, the spiral arms, the quiet neighbourhood where our sun burns today. All of it assembled slowly over billions of years of collisions and mergers and patient accumulation, until the galaxy became what it is tonight. A structure of extraordinary age and complexity, carrying within it the debris of 10 billion years of stellar birth and death. And somewhere in that debris, by processes science is still working to understand, you happened. Between the stars, the Milky Way is not empty. It is filled with something called the interstellar medium, a thin, cold scattering of gas and dust that occupies all the space between solar systems. In most places, it is almost nothing. Barely a handful of hydrogen atoms per cubic meter, thinner than the best vacuum humans have ever created in any laboratory on Earth. And yet it is not nothing. It carries magnetic fields that thread through the entire galaxy like invisible rivers. It carries cosmic rays, high-energy particles fired by dying stars, travelling through the galaxy at nearly the speed of light, passing through you right now, several of them every second, silently, without leaving any trace you can feel. It carries complex organic molecules, including some of the chemical building blocks of life, drifting between the stars in the cold dark, patient and ancient, waiting for a warm, rocky world to give them somewhere to go. The space between the stars only looks empty. Up close, with the right instruments, it hums with invisible activity, threaded with fields and particles and slow possibility. The Milky Way has a halo, not the kind in paintings, not a ring of light above the head, but an enormous, roughly spherical region of space surrounding the entire disk of the galaxy, extending far beyond the furthest visible stars, mostly invisible, mostly dark, mostly made of something we cannot directly detect. This halo contains a scattering of very old stars, some of the oldest in the galaxy, moving in wide looping orbits that carry them high above and below the flat disk of the spiral arms. It also contains what astronomers call dark matter, a substance that gives off no light, reflects no light, cannot be touched or measured directly, but whose gravity shapes the movement of everything around it. Dark matter makes up most of the mass of the Milky Way. More of our galaxy is invisible than visible. More of everything around us is hidden than shown. The universe keeps most of what it is to itself, offering only hints and edges and the way that things move as evidence that something vast and quiet is present. There is something almost personal about that, something worth sitting with in the dark. Stars in the Milky Way are not spread evenly. They cluster along the spiral arms, pack densely near the galactic centre, and thin out in the quieter regions where our Sun lives. Near the centre of the galaxy, stars are so close together that any planet orbiting one of them would have a night sky blazing with thousands of stars bright enough to cast sharp shadows on the ground. There would be no true darkness, no quiet black sky, just layers and layers of firelight from every direction, an overwhelming brilliance that never fully fades. And yet from here, from our calm address on the outer arm, the sky holds a manageable number of bright stars, and the rest is dark, and the dark is peaceful and restful. Our distance from the crowded centre may be one of the reasons complex life had enough time and stability to develop here, away from the radiation storms, away from the gravitational disruptions, in a temperate corner of a very busy galaxy. Quiet places have a kind of value that only becomes clear when you compare them to what lies closer to the centre. The Milky Way has been consuming other galaxies for most of its existence. This sounds violent, but it happens so slowly that no individual star feels it. Over hundreds of millions of years, a smaller galaxy drifts too close, is caught by the Milky Way's gravity, stretched and pulled apart like taffy, and gradually absorbed. Its stars fold into our own, losing their old identities, becoming part of something larger. Right now, the Milky Way is in the process of absorbing the Sagittarius dwarf galaxy, a small collection of stars that has been passing through the disk of the Milky Way repeatedly for billions of years, losing stars each time, slowly dissolving. Some of the stars currently in our galaxy may have originated in that ancient visitor, carried here by the long, patient pull of gravity over billions of years. We are not entirely what we started as. The Milky Way is a composite, a gathering of many things that were once separate mixed together now into something new. That, in its quiet way, feels like something worth knowing. In approximately 4.5 billion years, the Andromeda Galaxy will collide with the Milky Way. The two larger spirals in the local group are currently moving toward each other at about 110 kilometers per second. The collision will not be instant. It will unfold over hundreds of millions of years, the two galaxies passing through each other, their spiral arms distorting, separating, passing through again, before eventually merging into a single large elliptical galaxy. A vast, slowly rotating cloud of stars with no spiral arms, no clear structure, just an enormous collection of suns. The distances between individual stars are so vast that almost no stars will actually collide. The encounter will feel, to any planet caught inside it, less like a crash and more like a slow and extraordinary light show. New stars will be born from the compressed gas. The night sky will be filled with shapes and brightness, unlike anything alive today has ever imagined. Whatever looks upward from Earth in 4.5 billion years, if anything does, will see a sky of incomprehensible beauty. The universe is not finished being beautiful. The older stars in the Milky Way are nearly as old as the universe itself. They formed within the first few 100 million years after the Big Bang, when the only elements available were hydrogen and helium. No heavier elements existed yet because no stars had lived and died to create them. These ancient stars, sometimes called population 2 stars, carry almost none of the heavier elements that younger stars like our Sun are rich in. They are among the very first things that ever burned with nuclear fire. Some of them are still burning today, slowly and quietly, having outlasted almost everything that existed when they first ignited. They are older than Earth, older than the Sun, older than our entire solar system by billions of years. A few of them orbit through the halo of the Milky Way, on long, slow paths that carry them gently through the galaxy. They have witnessed everything, every collision, every new star, every galaxy that drifted too close and was absorbed. They have been turning for so long that the universe itself was unrecognizable when they began, and they are still there, still burning, patient in ways that no human word quite captures. The colour of a star tells you everything about how it lives. The hottest stars burn blue-white, ferociously bright, consuming their fuel so fast that they live for only a few million years, brilliant and brief, lighting up the spiral arms before vanishing. Cooler stars burn yellow like our Sun and live for 10 billion years or more, steady and reliable, the kind of star a planet can count on. The coolest stars of all burn a deep dim red, so faint they can barely be detected from Earth, but so long-lived that some of them may still be burning when the universe is 100 times its current age. The Milky Way contains all of these, blue giants blazing in the arms, yellow dwarfs burning quietly across the disk, and countless small red stars scattered everywhere, patient and nearly invisible, slowly outlasting everything else. The galaxy is not one colour. It is a spectrum, a full range of burning things at different temperatures and ages and speeds, each one a sun, each one a possible centre of something. And somewhere in that spectrum, one particular yellow star found a way to warm one particular small world just enough for something extraordinary to begin. The Milky Way is spinning right now, every part of it moving, rotating around the central mass, but not all at the same speed. Stars near the centre orbit more quickly. Stars farther out orbit more slowly, but not as much slower as the laws of physics would predict if only the visible matter were doing the pulling. The outer edges of the galaxy spin nearly as fast as the inner regions, which is deeply strange. In a system driven only by visible matter, the outer stars should be moving much more slowly, the way the outer planets of our solar system move more slowly than the inner ones. But they do not slow down as expected. They spin at nearly the same rate all the way to the edge. This was one of the first clues that dark matter exists. Something invisible, something massive, something distributed throughout the galaxy must be providing extra gravitational pull to keep those outer stars moving so fast. The galaxy holds together because of something we cannot see, something we have never directly detected, something we know is there only because of the way it moves everything else. The Milky Way is held in place by a mystery. Within the spiral arms of the Milky Way, there are places where new stars are being born right now. These are called stellar nurseries, vast clouds of cold gas and dust, sometimes dozens of light years across, dark and dense and silent from the outside. Inside them, something slow and powerful is happening. Small disturbances, the shock wave from a nearby explosion, or the gentle gravitational nudge of a passing cloud, cause regions of the gas to begin collapsing inward. Over millions of years, the cloud contracts and heats and compresses until at the very centre, the temperature becomes high enough to ignite nuclear fusion. A star switches on, and around it, the leftover gas and dust flattens into a spinning disk, cools, clumps together, and over tens of millions more years becomes a system of planets. This is how our own solar system formed 4.5 billion years ago, inside a stellar nursery that no longer exists, its gas long since consumed, its dust long since gathered into worlds. You are the end result of a process that began in a cold, dark cloud in a spiral arm of this galaxy. The nursery is gone. The cloud has become you. Stars in the Milky Way die in dramatically different ways depending on how massive they are. A star like our Sun will one day swell into a red giant, expanding to hundreds of times its current size, before gently shedding its outer layers in a slowly expanding shell of glowing gas and light. At its centre, the remaining core will compress into a white dwarf, a dense, Earth-sized object, no longer burning, slowly cooling over billions of years. Larger stars die differently and more dramatically. When a massive star exhausts its fuel, its core collapses in less than a second, and the rebound creates a supernova, an explosion so powerful it briefly outshines the entire galaxy that contains it. In that explosion, all the heavy elements forged deep in the star's core over its lifetime are flung outward into space at tremendous speed. The iron in your blood was made this way. The calcium in your bones was scattered by an explosion like this. The oxygen in every breath you take tonight was once inside a star that no longer exists. The endings of stars are not simply endings, they are the beginnings of everything that comes after. If you could travel at the speed of light, and nothing with mass ever can, crossing the Milky Way from one edge to the other would take 100,000 years. 100,000 years of travelling at the fastest speed the laws of physics permit, passing billions of stars, crossing the empty spaces between the arms, moving through clouds and nurseries and the glowing brightness of the central regions. And still, it would take 100,000 years to reach the other side. Every spacecraft ever launched by human beings combined would not have covered even the tiniest fraction of that distance. Voyager 1, humanity's most distant object, has been travelling since 1977 and is still barely beyond the edge of our own solar system, still within the outermost reaches of the Sun's gravitational influence, still nowhere near the first neighbouring star. The Milky Way is not a place you cross. It is a place you live inside, slowly, across timescales that dwarf all of human experience. We are not visitors here. We are residents. We belong to this. And knowing all of this, holding in mind even a fraction of the scale of the Milky Way, even a glimpse of what it contains, does not make the dark above you feel threatening. It makes it feel inhabited, full, ancient and patient and quietly magnificent. You're not a small thing lost in a large universe. You're a part of this, embedded in it, made of materials that were forged in its stars and scattered through its arms, and gathered slowly by processes spanning billions of years into something that can lie here and breathe and listen and feel, a small, quiet wonder at the size of the thing it belongs to. The galaxy is above you right now, turning. The stars are out there, all of them, burning and drifting and moving in their enormous slow orbits. And there is still so much more to tell you. 80 more quiet truths, each one waiting just ahead in the dark. The Milky Way has a bar, not a drinking establishment, but something far more remarkable. A thick elongated structure of stars crossing the very centre of the galaxy, a kind of glowing bridge connecting the inner spiral arms. When astronomers map the galactic centre in infrared light, which can penetrate the dust that blocks visible light, they see not a round central hub but this elongated bar, rotating slowly, its gravitational influence shaping everything around it. Bars like this are common in spiral galaxies. Roughly 2/3 of all spirals observed from Earth have them. They form when the orbits of stars in the central disk begin to align and pile up along a common axis, creating a stable rotating structure that then influences how gas flows inward toward the central black hole. The bar of the Milky Way is thought to be roughly 27,000 light-years long. It rotates once every 100 million years or so, its slow-turning, stirring gas inward, feeding the central regions, keeping the whole inner structure in a state of gentle, continuous motion. The galaxy's heart is not a simple bright ball of stars. It is layered and dynamic and full of structure that took decades of careful observation to begin to understand. The Milky Way is still growing. Even now, as you lie here, the galaxy is pulling in fresh material from outside. Gas streaming in from the surrounding intergalactic medium, stars captured from smaller satellite galaxies, dark matter flowing in along the threads of the cosmic web. It grows not with sudden visible change, but with the slow, patient accumulation of mass over millions of years, adding to its halo, adjusting its shape, incorporating what drifts close enough to be caught. The galaxy you live in today is not the one the first dinosaurs saw. It is heavier. It has absorbed more. Its outer regions have been stirred by encounters with smaller galaxies that no longer exist as independent structures. In 1 billion years, it will be different still. Larger, richer in stars, perhaps already in the early stages of its collision with Andromeda. Galaxies are not finished objects. They are ongoing projects, still assembling, still consuming, still becoming whatever they will eventually be. The Milky Way is a work in progress, and so, in the most generous sense, is everything inside it. There are stars in the Milky Way that orbit in the wrong direction. Most stars in the disk orbit the galactic center in the same general direction, the same direction the disk itself rotates, the same direction the spiral arms wind. But some stars, particularly in the outer halo, travel in retrograde, circling the center in the opposite direction, against the flow. These backward travellers are thought to be immigrants, stars that originated in smaller galaxies that were absorbed by the Milky Way long ago. When a dwarf galaxy is pulled apart by tidal forces, its stars scatter into the halo and continue orbiting, but they carry the memory of their original galaxy's motion, which may have been oriented differently. Their reversed orbits are a kind of signature, a quiet announcement of foreign origin. The galaxy carries within its motion the preserved histories of everything it has ever consumed, written not in any language, but in the directions that stars travel through the dark. Above and below the Milky Way's disk, stretching tens of thousands of light years in both directions, there are two enormous structures that glow in gamma rays, a form of radiation so energetic it is invisible to human eyes, detectable only by space telescopes. These are called the Fermi bubbles, named after the telescope that first detected them. They extend like two vast lobes from the center of the galaxy, each one spanning about 25,000 light-years, and no one is entirely certain what created them. The leading theories involve either a massive outburst from the central black hole, which may have been far more active millions of years ago, or an intense period of star formation in the galactic center that released enormous energy over a sustained period. Either way, these invisible structures are enormous. If you could somehow see them with human eyes, they would appear larger in the night sky than the constellation Orion. They are among the largest known structures in the Milky Way, and they hang silently above and below the disk, glowing in light we cannot see, reminding us that the galaxy is full of features we're only now beginning to discover. The Milky Way's disk has two distinct layers. The thin disk, where our solar system lives, is the bright, dense plane of the galaxy, rich with young stars, star-forming clouds, and the blue-white light of recently ignited suns. It is roughly 1,000 light-years thick, and is where most of the galaxy's current activity happens. But above and below it sits what astronomers call the thick disk. older, puffier, more diffuse, populated by stars that are typically several billion years older than the thin disk stars. The thick disk stars orbit on more tilted and elliptical paths, suggesting they formed under different conditions or were disturbed by ancient galactic collisions early in the Milky Way's history. The two layers overlap and blend. There is no sharp border between them, but their populations are distinct in age, chemistry, and motion. The galaxy's disk is not a single flat sheet. It is a layered structure, each layer telling a different part of the galaxy's long story, like the rings of a tree recording different years in different widths of wood. Across the sky, if you knew where to look and had the right instruments, you would find thin ribbons of stars stretching in long arcs and curves, faint, delicate, and almost imperceptible against the general glow of the galaxy. These are stellar streams, the remnants of smaller galaxies and star clusters that wandered too close to the Milky Way and were pulled apart by tidal forces. As they orbited, their stars were gradually smeared across space, drawn out into long trails that trace the paths of their former homes. Some of these streams wrap partway around the galaxy, others dive in toward the centre. All of them are evidence of the Milky Way's history of consumption, quiet marks left by structures that no longer exist as independent things. The Sagittarius stream, one of the longest, wraps nearly all the way around the sky, a monument to the slow destruction of the Sagittarius dwarf galaxy over billions of years. The sky is full of these ghost trails. The galaxy keeps records of everything it has ever taken in. The Milky Way's disk is warped. It does not lie perfectly flat like an idealized spiral. Instead, it bends, the outer regions tilting upward on one side and downward on the other, creating a gentle wave shape that extends across tens of thousands of light years. This warp is most visible in the gas that extends beyond the main stellar disk, and it is thought to be caused by gravitational interactions with the large and small Magellanic Clouds, two satellite galaxies visible from the southern hemisphere, orbiting the Milky Way and tugging on its outer edges as they move. Some researchers think the warp is also influenced by clumps of dark matter in the halo, pulling on the disk from different directions as the galaxy moves through space. The warp is not a static feature. It precesses, rotating slowly over time like a spinning top that has been nudged slightly off balance. The Milky Way is not a perfect flat spiral. It is a living, flexing structure, responding to the gravitational company it keeps. On a clear dark night with no moon and no nearby city lights, a careful human eye can see approximately 5,000 stars. That sounds like a lot, and in a dark field it feels like an ocean of light. But the Milky Way contains between 200 billion and 400 billion stars. The fraction visible to the naked eye is roughly 5,000 divided by 300 billion, a number so small it has no meaningful intuitive equivalent. We are seeing an extraordinarily tiny sample of a structure so dense that our unaided vision barely scratches its surface. Most stars are hidden by distance. Many more are hidden by the dust that fills the galaxy's disk, absorbing their light before it reaches us. The Milky Way that crosses the sky on a dark night is just the whisper of the thing, the barest edge of something far too large and too full to be seen all at once from inside it. What we see is not the galaxy. It is the suggestion of the galaxy. The interstellar medium, the thin gas and dust between the stars, is not calm, it is turbulent. It churns and swirls on scales ranging from the very small to hundreds of light years across, stirred by the shock waves of supernovae, by the winds blowing from massive stars, by the gravitational influence of spiral arms passing through. These turbulent flows are not random. They follow patterns governed by magnetism and gravity and the specific chemistry of the gas. They carry energy from large scales down to small ones, eventually concentrating it in dense cold pockets where new stars begin to form. The turbulence of the interstellar medium is one of the things that makes the Milky Way a living system rather than a static collection of points of light. The space between stars is not just empty background, it is a dynamic medium, active and churning, part of the same ongoing process that has been forming stars and planets, and eventually everything on them for 10 billion years. The Milky Way produces new stars at a rate of roughly 1 to 3 new suns per year on average, a much slower rate than it managed in the first few billion years of its existence, when gas was more plentiful and denser, and the galaxy was actively assembling itself. In its early life, the Milky Way may have been forming stars at 10 or 20 times today's rate, blazing with the light of massive short-lived blue giants, its arms bright with the violence of rapid starbirth. Now, in what astronomers call the galaxy's middle age, star formation has settled into a gentler pace. There is still gas, still active stellar nurseries, still new suns being ignited in the dark, but the frenzy of youth has quieted. The Milky Way is maturing, settling into the slower rhythms of a galaxy that has done most of its major building. 1 to 3 new suns per year, accumulating quietly, generation after generation, in the long, slow, darkening afternoon of galactic time. Some stars in the Milky Way have been flung outward at extraordinary speeds, fast enough to eventually escape the galaxy entirely. These are called hypervelocity stars, and some of them are thought to be the products of close encounters with the supermassive black hole at the galactic centre. When a binary star system, 2 stars orbiting each other, drifts too close to Sagittarius A star, the black hole's enormous gravity can disrupt the pair. One star falls inward and is captured. The other is flung outward at tremendous speed, sometimes more than 1,000,000 kilometers per hour, launched into a one-way journey away from the galaxy. These rogue stars travel alone, far from the disk, heading outward into the intergalactic void with nothing ahead of them and nothing to slow them down. They carry within them the chemical fingerprints of wherever they were born, evidence of their origin, their expulsion, a kind of violent biography written in motion. Globular clusters are among the oldest structures in the Milky Way, compact, roughly spherical collections of hundreds of thousands of stars tightly bound by their mutual gravity, orbiting the galactic centre in the halo on long looping paths. The Milky Way has more than 150 of them, each one a kind of ancient city of stars, some of them over 12 billion years old, nearly as old as the universe. The stars inside them are packed so densely that near the centre of a large globular cluster, stars are separated by distances measured in fractions of a light year, rather than the several light years typical of our own neighbourhood. The night sky from a planet in the core of a globular cluster would be extraordinary, brilliant with the light of hundreds of thousands of nearby stars, never truly dark, a permanent blaze in every direction. These clusters drift silently through the halo, survivors of the galaxy's earliest epochs, unchanged in their essential character for billions of years, keeping a kind of living record of the conditions that existed when they formed. The Sun does not travel in a perfectly flat orbit around the Milky Way. As it moves along its path, it also bobs gently up and down through the galactic plane, oscillating above and below the disk's midpoint in a slow wave motion that takes roughly 60 to 70 million years to complete each cycle. This vertical wobble is caused by the gravitational pull of the concentrated mass of the disk, which draws the Sun back down when it drifts above it, and then pulls it back up again when it dips below. The amplitude of this oscillation is relatively small. The Sun wanders only a few hundred light years above or below the plane, but it means that over the course of Earth's history, our solar system has repeatedly passed through regions of higher and lower star density, different magnetic field strengths, and varying cosmic ray intensities. Some researchers have wondered whether these passages might have influenced climate patterns or extinction rates on Earth over geological time. The evidence is uncertain, but the motion itself is real. The Sun is not simply orbiting the galaxy. It is also swaying through it, gently, on a rhythm measured in tens of millions of years. The Milky Way's total mass, including all its stars, gas, dust, and the enormous dark matter halo surrounding it, is estimated to be somewhere between 800 billion and 1.5 trillion times the mass of the Sun. The uncertainty in that estimate is enormous, and it is not due to careless measurement. It is due to the fundamental difficulty of measuring the influence of dark matter, which dominates the galaxy's mass but cannot be directly observed. Scientists infer the mass from the motions of stars and satellite galaxies at large distances, working backward from how fast things orbit to calculate how much mass must be pulling on them. Different measurement techniques give different answers. Some suggest the Milky Way may even outweigh Andromeda despite appearing slightly smaller and less luminous, because the dark matter halo may extend further and be denser than previously estimated. The weight of our home galaxy is not precisely known. We live inside something we cannot fully measure. The Milky Way sits within a larger structure called the local sheet, a broad flat arrangement of galaxy groups that includes our local group and several neighbouring groups, all moving together in a roughly coordinated way. Beyond the local sheet lies the Virgo supercluster, a massive concentration of thousands of galaxies with the giant Virgo cluster at its centre. And beyond even that, the Milky Way belongs to a structure called Laniakea, an enormous supercluster stretching over 500 million light-years, in which the Milky Way is just one of approximately 100,000 galaxies, all flowing together under the influence of a gravitational focal point called the Great Attractor. We are a small galaxy in a large group in a supercluster in a cosmic web that stretches in all directions beyond the reach of any telescope ever built. The address keeps expanding the further out you look, and somehow, in all of that, here you are. The disk of the Milky Way is enriched with heavy elements, carbon, oxygen, iron, silicon, and dozens of others that did not exist when the universe was young. All of these heavier elements were forged inside stars and scattered by supernovae, building up over generations of stellar birth and death until the gas of the galaxy became chemically rich enough to form planets like Earth and, eventually, living things. This process is called chemical enrichment, and it is one of the most important stories in the history of the universe. The early Milky Way was a simpler place, mostly hydrogen and helium, barely capable of making rocky planets, certainly not capable of making the complex chemistry that life requires. It took billions of years of stellar generations, each one dying and contributing its heavier elements to the next round of star formation, before the galaxy reached a state where something like the solar system was possible. You exist because countless stars lived and died before you. Their endings made your beginning possible. Some regions of the Milky Way are more hospitable to life than others. In the dense, radiation-intense inner regions near the galactic centre, the environment may be too harsh for complex life to develop. Too many supernovae, too much cosmic radiation, too much gravitational chaos. In the sparse outer regions far from the centre, the gas is too poor in heavy elements to form Earth-like planets easily. Between these extremes lies what some astronomers call the galactic habitable zone, a broad ring of the disk where conditions are relatively stable, heavy elements are available, stellar density is moderate, and the radiation environment is not overwhelming. Our solar system sits within this zone. Whether life exists elsewhere in the Milky Way we do not yet know, but the conditions that allowed it to arise here are not unique to our exact location. They exist across a wide swathe of the galaxy, in billions of star systems scattered through the disk, each one a possible address, each one a possible answer to a question we have not yet been able to ask in the right way. The Milky Way, for all its complexity, is ultimately a machine for making stars, drawing in gas, compressing it, igniting it, letting the stars live and die and scatter their material, then gathering it again into new stars enriched with everything the previous generation built. It is a cycle that has been running for 10 billion years, each revolution leaving the galaxy slightly more chemically complex, slightly more capable of producing the kinds of worlds where chemistry can organize itself into something that wonders about the galaxy it lives in. You are a product of this cycle, not metaphorically, literally. The atoms of your body have passed through this process, born in stars, scattered by explosions, gathered into clouds, compressed into a new solar system, incorporated into a planet, organized by chemistry and time into something alive. The Milky Way made you, and somehow, impossibly, it made you capable of knowing that. There is still much more waiting in the dark ahead. 60 more quiet truths, drifting toward you like light from a very patient source. There is a star in the halo of the Milky Way that is nearly as old as the universe itself. Astronomers have found it, studied it, measured the almost undetectable traces of heavy elements in its ancient atmosphere, and concluded that it formed somewhere around 13 billion years ago. A few 100 million years after the Big Bang, when the universe was still in its earliest youth and the Milky Way was just beginning to assemble its first rough shape. This star has no name that most people know. It sits quietly in the outer reaches of the galaxy, burning at a low temperature with a dim reddish glow, moving in a slow, wide orbit that carries it through the halo over billions of years. It has been burning since before Earth existed, since before the Sun existed, since before almost any star you've ever heard of existed. It has watched the galaxy form around it, watched the spiral arms develop, watched generations of stars ignite and die and scatter their material, watched the whole long process by which the galaxy became rich enough in heavy elements to eventually make worlds like ours. And it is still there, still burning, a living relic from the universe's first dawn, drifting quietly through the dark, older than almost everything. The light from the stars you see tonight has been travelling for a very long time. The nearest star to our Sun, Proxima Centauri, is about 4.2 light-years away, which means the light from it that reaches your eye tonight left its surface 4 years ago. The star Betelgeuse, the bright reddish point in Orion's shoulder, is about 700 light-years away. So what you see when you look at it is what it looked like 700 years ago, before Columbus crossed the Atlantic, before the printing press existed, before almost everything you would recognise as modern history. Some of the faint stars visible on a dark night are thousands of light-years away, meaning the light left them before the Roman Empire fell, before the pyramids were built, before writing existed anywhere on Earth. The night sky is not a window into the present. It is a collection of postcards from different times, all arriving simultaneously, each one showing a moment that is already irretrievably past. You are reading the galaxy's mail. You're receiving messages from 1,000 different epochs all at once. When you breathe in tonight, you're breathing atoms that have been part of this galaxy for billions of years. The oxygen in every breath you take was forged inside massive stars that lived and died before the Sun existed. The nitrogen in the air around you has similar origins. The carbon in every cell of your body was created in stellar cores, in the specific temperatures and pressures found only at the heart of burning stars, where hydrogen fuses into helium and helium into carbon, in a slow, patient nuclear dance. These atoms were scattered into space when those stars exploded, drifted through the interstellar medium for millions of years, were gathered into the cloud that collapsed to form our solar system, incorporated into the early Earth, and eventually, through processes that science is still working to fully understand, ended up in you. You are not visiting the Milky Way. You are made of it. Your body is a temporary arrangement of galactic material on loan from a universe that has been recycling the same atoms for most of its existence. The Milky Way is not symmetrical, and that asymmetry carries information. One side of the disk is slightly thicker than the other. The spiral arms are not mirror images. Some are brighter, some are longer, some curve more sharply than others. The stellar halo is slightly off-center relative to the disk. These imperfections are not flaws. They are the preserved marks of the galaxy's history. Gravitational encounters with satellite galaxies, ancient mergers that left slight imbalances behind, the ongoing tug of the Magellanic Clouds on the outer edges of the disk. If the Milky Way were perfectly symmetric, it would suggest a history of perfect isolation, undisturbed development in a vacuum. Its imperfections tell the truth. The galaxy has not been alone. It has been shaped by everything around it, every encounter adding another small asymmetry to the structure, every interaction leaving its signature in the way the disk tilts or the arms curve. The galaxy is irregular because it is experienced, because it has been through things, because it has a history. At the heart of the Milky Way, the stars orbit the central black hole at extraordinary speeds. The star known to astronomers as S2, one of a group of stars discovered orbiting close to Sagittarius A star, completes a full orbit in just about 16 years. 16 years to circle an object 26,000 light-years away. To accomplish this, S2 travels at a speed of roughly 7,000 kilometers per second at its closest approach, nearly 2.5% of the speed of light. Einstein's theory of general relativity predicts that at such speeds, in such strong gravitational fields, time itself flows slightly differently. The star's clocks, if it had them, would run slower than clocks far away from the black hole. And when astronomers measured the light from S2 carefully, they found exactly this effect. Time near the galactic center does not flow at the same rate as time out here. The universe's rules apply everywhere, but they apply differently depending on how much gravity is present and how fast you're moving. The galaxy is not only large in space, it is also varied in time. The Milky Way generates cosmic rays, extremely high energy particles, mostly protons and atomic nuclei, accelerated to nearly the speed of light by the shock waves of supernovae and by the powerful magnetic fields near the galactic center. These particles travel through the galaxy at almost the speed of the light, bouncing off magnetic field lines, filling the disk with a constant invisible rain of energetic particles. Several of them pass through your body every second. You cannot feel them. They carry no sensation you are equipped to detect. But they are real, and they have been real for the entire history of your life, passing through you in your earliest infancy, passing through you now, carrying within them the encoded history of the stellar events that created them, the specific energies and compositions that tell physicists where they came from and what produced them. The galaxy is not only visible light and radio waves, it is also this constant invisible flux, an environment of particles and fields that permeates everything, including you, passing through without consequence and without ceremony. The spiral arms of the Milky Way are not made of fixed stars. This is one of the most important and least intuitive facts about the galaxy's structure. If you could watch the Milky Way for hundreds of millions of years and fast forward, you would see something surprising. The stars drift in and out of the arms. The arms themselves move at a different speed than the stars do, passing through the disk like a slow wave. As the wave passes through a region of gas and dust, it compresses the material, triggering new star formation. Young bright stars ignite in the arm, light it up, and then drift out of it as the arm moves on to compress new material elsewhere. The spiral arms are patterns, density waves. not permanent structures of fixed stars. They are more like traffic patterns than roads. The stars pass through them the way cars slow down in a traffic jam and then emerge on the other side. The spiral shape is real and it is beautiful, but it is an illusion of permanence. What looks like a fixed structure is actually a wave moving through something that is always in motion. There's a kind of star in the Milky Way called a magnetar, a neutron star with a magnetic field, so powerful it is almost beyond description. The magnetic field of a typical refrigerator magnet is about 100 Gauss. Earth's magnetic field is about 1 Gauss. The magnetic field of a magnetar can reach 10 to the power of 15 Gauss, a quadrillion times stronger than Earth's. At that field strength, atoms are stretched into thin cylinders, the electrons of every atom compressed along magnetic field lines, ordinary chemistry made impossible. If you were as far from a magnetar as the distance from Earth to the Moon, the magnetic field would be strong enough to disrupt the iron in your blood. These objects are rare. Only about 20 or so are known in the Milky Way, but they are among the most extreme physical environments the universe produces. They occasionally release sudden bursts of X-rays and gamma rays called starquakes, brief brilliant flares that for a fraction of a second can outshine the entire galaxy. They are proof that the universe contains things so extreme that even our most powerful mathematics struggles to describe them comfortably. The Milky Way is surrounded by a vast collection of satellite galaxies, smaller galaxies orbiting our own the way moons orbit planets. The most prominent are the large and small Magellanic Clouds, visible to the naked eye from the southern hemisphere as two bright smudges of light in the dark sky. But beyond these famous companions, there are dozens of smaller, fainter satellite galaxies, ultra-faint dwarfs barely detectable even with powerful telescopes, made of just millions of stars instead of billions, so dim and so sparse that they are mostly dark matter, with a scattering of ancient stars. Some of these satellites are being tidally disrupted, their stars slowly drawn out into streams by the Milky Way's gravity. Others orbit peacefully in the halo, ancient companions that have been circling our galaxy for billions of years. Recent surveys have dramatically increased the number of known satellite galaxies. Astronomers expect to find even more as telescopes improve. The Milky Way is not alone. It moves through space surrounded by a retinue of smaller companions, each one a small world of its own, each one adding to the complexity of the system we inhabit. Every atom heavier than hydrogen in the Milky Way was made inside a star. This includes every atom of oxygen in every ocean on every planet that has ever formed in this galaxy. Every atom of iron at the core of every rocky world, every atom of carbon in every organism that has ever lived anywhere in the Milky Way's 10 billion year history. The universe began with almost only hydrogen and helium. The Big Bang produced these two lightest elements in abundance, and traces of lithium and beryllium, but nothing heavier. Everything above that on the periodic table, every element that makes chemistry interesting, every element that makes planets solid and oceans wet and biology possible, was manufactured inside stars in the specific conditions of stellar interiors and stellar explosions, and distributed through the galaxy by the winds and deaths of those stars. The Milky Way is a factory. It has been making new elements for 10 billion years, each generation of stars leaving the galaxy more chemically rich than the last. The complexity of the periodic table is not a given. It was earned slowly by the living and dying of stars beyond counting. The Milky Way emits light in wavelengths invisible to human eyes. In radio waves it glows with the emissions of cold hydrogen gas and the pulses of rotating neutron stars. In infrared light, the warm dust in the disk shines clearly, revealing the spiral structure hidden behind optical obscuration. In ultraviolet light, the hot young stars in the arms blaze with the particular intensity of recently ignited nuclear fires. In X-rays, the collapsed stellar remnants, white dwarfs stealing gas from companions, neutron stars spinning in binary systems, shine with the violent energies of extreme physics. In gamma rays, the Fermi bubbles glow above and below the plane, and the central black hole occasionally flares with X-rays from infalling material. The galaxy that looks like a soft river of white light to human eyes is, in truth, a richly layered object that radiates across the entire electromagnetic spectrum, each wavelength revealing a different layer of the structure, each frequency telling a different part of the story. We see one narrow band of the galaxy's full expression. The rest has been waiting for instruments sensitive enough to receive it. The Milky Way's magnetic field threads through the entire disk, winding along the spiral arms, rising into the halo in loops and arcs, shaping the motion of charged particles and influencing how gas clouds collapse and form stars. It is weak by everyday standards, a few millionths of a gas, far too faint to deflect a compass needle. But over galactic distances it becomes enormously important. It helps guide cosmic rays through the disk, bending their paths and determining how long they spend in different regions before escaping into intergalactic space. It influences the alignment of dust grains in the interstellar medium, leaving a detectable imprint on the polarization of starlight that passes through. It plays a role in the formation of new stars, providing pressure support that slows or regulates the collapse of gas clouds. The galaxy has a magnetic personality, not visible, not directly tangible, but present in everything, shaping the environment in ways that become clear only when you look at how particles and gas behave in its presence. The Sun's position in the Milky Way may not be coincidental. We sit roughly 2/3 of the way from the centre, not in the dense inner regions, not in the sparse outer reaches, but in what some astronomers describe as the galactic habitable zone. This region of the disk has enough heavy elements from previous stellar generations to form rocky planets and complex chemistry, but not so many supernovae and not so much radiation that life would be constantly disrupted. The Sun also sits near something called the corrotation radius, the distance from the centre at which a star's orbital speed matches the speed of the spiral arms. Stars at this radius cross the spiral arms infrequently, spending long periods in the relatively calm spaces between them. This may have given our solar system the uninterrupted billions of years of stability that complex life apparently requires. Whether this is chance or selection bias, life can only arise in places that allow it, remains an open question. But the address is a good one. The Milky Way has a name that comes from the way it looks in a dark sky. In many languages, the name reflects the same observation, a spilled or scattered thing, pale and diffuse stretching across the heavens. The ancient Greeks called it the Milky Circle, a band of pale light they imagined as spilled milk from the breast of Hera. The Romans borrowed and translated the term, giving rise to Via Lactea, the Milky Way. In ancient India, the galaxy was called the Akash Ganga, the Ganges of the sky. In the Arab world, it was the Milky Circle or the River of Heaven. Every culture that looked up at a dark enough sky saw the same thing and reached for the same kinds of metaphors: rivers, spills of light, roads across the heavens. The specific stories differ. The sense of recognition, of something familiar in something vast, is universal. Human beings looked at the faint smear of 100 billion stars and saw something they already knew. That instinct to find the familiar inside the enormous has always been part of how we make sense of the sky. The first reliable estimate of the size of the Milky Way came from an astronomer named Harlow Shapley. who in the early 20th century mapped the positions of globular clusters across the sky and noticed they were not evenly distributed. They clustered preferentially toward the constellation Sagittarius, which suggested that the centre of the galaxy lay in that direction. From the distribution of the clusters, he estimated the galaxy's size. His numbers were not perfect by modern standards, but the basic insight was correct. Before Shapley, many astronomers assumed the Sun was near the centre of the galaxy. After his work, it became clear we were in the outskirts, not the centre of things, but a minor address in a system far larger than previously imagined. It was one of the great demotion events in the history of astronomy, a displacement of human perspective from the centre outward, following the earlier discoveries that Earth is not the centre of the solar system, and the Sun is not unique among stars. Each correction in perspective has made the universe larger. Each one has required a certain kind of courage to accept. The Milky Way will one day stop forming stars. Not soon, not for billions of years, but eventually the supply of cold gas available for star formation will be exhausted, drawn down by generation after generation of starbirth, consumed into stellar remnants, lost to galactic winds, unable to be replenished fast enough to maintain the current rate of formation. When that time comes, the galaxy will slowly fade. The existing stars will age. The most massive will die quickly, taking their blue light with them. The medium-sized stars will live their billions of years and then cool to white dwarfs. Eventually, only the smallest, coolest red dwarfs will remain, still burning, still faintly glowing, but fewer and fainter and further apart as the galaxy dims over trillions of years toward a quiet and nearly lightless old age. This is not imminent. The Milky Way has billions of years of active life ahead, but it is the direction time is going. The galaxy, like everything in the universe, is temporary. Its beauty is real, and it is finite, which in its way makes it more beautiful, not less. The Milky Way contains dark molecular clouds, regions of the interstellar medium so dense and cold that they absorb all visible light passing through them, appearing as black patches against the star field behind. Some of these clouds are called dark nebulae, and they are visible on clear nights as oddly empty regions within the Milky Way's glow. The coal sack near the Southern Cross, the great rift that divides the bright band of the galaxy in two across large stretches of the sky. These dark patches are not holes in the galaxy. They are clouds so thick with dust that the billions of stars behind them are completely hidden. Inside them, at temperatures close to absolute zero, gas molecules form and chemistry begins. Simple molecules at first, then more complex ones. The slow, patient construction of the chemical conditions that lead eventually to stellar birth. What looks like absence is preparation. What looks like darkness is the beginning of light. The universe has a talent for hiding its most creative work behind silence and dark. The Milky Way recycles everything. Stars are born from gas and dust. They burn for millions or billions of years. They die and return their material to the galaxy, enriched now with heavier elements, scattered back into the interstellar medium by stellar winds and supernova explosions. That enriched gas cools and drifts and eventually joins new clouds, which collapse under gravity and form new stars. The cycle has been running for 10 billion years. Every atom in the galaxy has probably been through this process multiple times. Inside a star, then outside, then inside another, then scattered again, then gathered again. Nothing is wasted. Nothing is lost. The galaxy breathes in and out across enormous timescales, taking simple light elements and slowly transforming them into the full richness of the periodic table. You are part of this cycle. The atoms of your body are between stars right now, temporarily organized into something that thinks and breathes and rests. They have been here before. They will be here again. The number of planets in the Milky Way is almost certainly in the hundreds of billions. Data from missions like Kepler and from ground-based surveys has shown that planets are not rare. They are the expected outcome of star formation, a natural consequence of the way disks of gas and dust behave around newly formed stars. Most stars have planets. Many have multiple planets. Smaller rocky planets may be even more common than larger gas giants. Applying these statistics to the full population of stars in the Milky Way gives an estimate of hundreds of billions of planets, perhaps more planets than stars, when you count the smaller worlds orbiting dim red dwarf stars. Most of these planets will never be visited. Most will never be named. They spin and orbit in silence, unknown, undetected, carrying whatever their surfaces hold, rock, ice, ocean, air, or nothing, through their own long years around their own quiet suns. The galaxy is not a collection of stars. It is a collection of worlds. Pulsars are among the most precise timekeepers in the universe. When a massive star collapses into a neutron star, and the remnant is left spinning rapidly, it can emit narrow beams of radio waves from its magnetic poles, like a cosmic lighthouse, sweeping the beams through space with each rotation. From Earth, we detect a regular pulse every time one of these beams sweeps past. Some pulsars rotate hundreds of times per second, their timing so regular that they rival atomic clocks in precision. By monitoring networks of pulsars spread across the sky, astronomers can detect tiny disturbances in space-time, gravitational waves from merging black holes and neutron stars passing through Earth, stretching and compressing the distances between the pulsars by minute amounts. The galaxy is full of these natural clocks, ticking in the dark, keeping time with extraordinary accuracy, their steady pulses carrying information about the physics of matter under conditions that no human laboratory can replicate. There are regions in the Milky Way where star formation is happening right now, tonight, as you rest. The Orion Nebula, visible to the naked eye as a faint smudge below the three belt stars of Orion, is a stellar nursery less than 1,500 light-years away, practically next door in galactic terms. Inside it, dozens of new stars have formed in the last million years, many of them surrounded by protoplanetary disks that may already be in the process of assembling planets. The Eagle Nebula, home to the famous Pillars of Creation, towering columns of gas and dust photographed by the Hubble Space Telescope, is another active star-forming region, its dark pillars sculpted by the radiation and stellar winds of nearby massive stars. Star formation is not something that happened only in the ancient past. It is ongoing. The galaxy is not finished. New suns are switching on right now, in the dark between the spiral arms, in cold clouds collapsing under gravity's patient instruction. The story is still being written. Neutron stars, the collapsed cores left behind by certain supernova explosions, pack roughly the mass of the Sun into a sphere about the size of a city. A teaspoon of a neutron star material would weigh approximately 1 billion tons on Earth. The density is so extreme that atomic nuclei are packed directly against each other. Their electrons squeezed into the protons to form neutrons, creating a state of matter that exists nowhere else in the observable universe except in these stellar remnants, and possibly in the first moments after the Big Bang. The surface gravity of a neutron star is roughly 200 billion times the surface gravity of Earth. If you could somehow stand on one, which would of course be impossible, you would weigh more than all of humanity combined. These objects exist throughout the Milky Way, quietly spinning in the dark, each one a monument to the extraordinary violence of its origin and the extraordinary physics of its current state. The galaxy is not only made of things we can easily imagine. It contains conditions that strain the very language we use to describe matter. The Milky Way's central black hole was almost certainly more active in the past. Today, Sagittarius A star is relatively quiet. It occasionally flares when infalling gas heats up as it spirals inward, producing brief bursts of X-rays, but it is nothing like the blazing quasars seen at the centres of other galaxies. Some of those quasars are Milky Way-sized galaxies whose central black holes are actively consuming enormous amounts of material, shining with the light of trillions of suns. Our central black hole may once have been similarly active. In the early universe, when gas was more plentiful and galaxies were more chaotic and mergers more frequent, Sagittarius A star may have blazed with quasar-like intensity, lighting the young Milky Way from within. The Fermi bubbles stretching above and below the galactic centre may be one of the lasting signs of that earlier, more violent phase. The quiet black hole at the centre of our galaxy may carry within its structure the memory of a much louder past. The space between galaxies, the intergalactic medium, is not truly empty. It contains thin streams of gas flowing along the filaments of the cosmic web, connecting galaxy groups and clusters in a vast structure that spans the observable universe. Some of this gas flows into the Milky Way, replenishing the supply available for star formation. High-velocity clouds, large masses of gas moving at speeds inconsistent with simple galactic rotation, are thought to be infalling material from outside the galaxy, fresh hydrogen streaming in along gravitational channels, providing the raw material for future generations of stars. The Milky Way is not a closed system feeding only on what it contains. It is connected to the larger universe by these flows of gas, embedded in a cosmic web that links it to structures hundreds of millions of light years away. The galaxy breathes in from the universe around it. White dwarfs are the final state of stars like our Sun. After a Sun-like star exhausts its nuclear fuel and sheds its outer layers, what remains is the compressed core, a sphere roughly the size of Earth, but containing roughly half the mass of the original star, made mostly of carbon and oxygen, no longer burning with nuclear fire, simply hot from its violent past and slowly, over billions and billions of years, cooling toward darkness. The Milky Way contains hundreds of billions of white dwarfs, the cooling remnants of every Sun-like star that has completed its life cycle in the galaxy's 10 billion year history. The oldest white dwarfs in the galaxy are so cool that they have faded to a dim reddish glow, or even cooled to near invisibility. These ancient remnants carry within their compositions a record of the temperatures and densities at which they formed. They're quiet, fading things, the preserved cores of stars that once warmed their own solar systems, now drifting in the dark, slowly surrendering their heat to the long cold of space. The Milky Way is not visible the same way from all places on Earth. From the southern hemisphere, the galactic centre, the brightest and most densely starred region of the Milky Way, rises high in the winter sky, blazing in the constellation Sagittarius, visible overhead on dark, clear nights with an intensity that observers in the northern hemisphere rarely experience. In the northern hemisphere, the centre sits lower on the horizon and is more obscured by the atmosphere at the angles from which it is viewed. Indigenous peoples of the southern hemisphere, the Aboriginal Australians, the Mapuche of South America, the Maori of New Zealand, developed rich and complex relationships with the Milky Way precisely because of how dramatically it dominates their night sky. Some Aboriginal traditions include what are called dark constellations, shapes identified not in the bright stars but in the dark clouds of dust and gas that cut through the Milky Way's glow. The emu in the sky, a figure traced in the dark patches of the galactic band. A tradition of reading absence as presence, of finding meaning in the dark between the lights. The Milky Way's disk is approximately 100,000 light-years across, but only about 1,000 light-years thick in the region where our solar system lives. a ratio similar to that of a compact disk. It is an extraordinarily thin structure for its width, maintained in its flatness by the rotation of the galaxy and the gravitational dynamics of the disk itself. Despite this thinness, there is still considerable vertical structure. The thin disk sits within the thicker disk, which sits within the halo, each layer with its own population of stars and its own range of ages and compositions. From the side, the Milky Way would look like a thin glowing lens, bright at the centre and fading outward, with faint wisps of the halo extending above and below. It is one of the most elegant structures in the observable universe. An enormous flat spinning disk of burning points of light, held together by gravity, turned by momentum, maintained by the balance of forces that has kept it essentially stable for billions of years. The Milky Way contains regions of extraordinarily dense star formation called starburst regions, areas where gas has been compressed by galactic interactions or internal dynamics, triggering star formation at rates far higher than the galaxy's average. In these regions, new stars ignite so quickly and in such concentration that their combined radiation and stellar winds carve enormous cavities in the surrounding gas, creating complex structures of hot bubbles and cold shells that drive the next generation of star formation. The central region of the Milky Way itself shows signs of episodic starburst activity, periods of intense star formation separated by quieter intervals. The galaxy does not form stars at a perfectly steady rate. It has rhythms, periods of greater and lesser activity driven by the availability of gas, by interactions with satellite galaxies, by the occasional disruption of the interstellar medium by nearby supernovae. The history of star formation in the Milky Way is a heartbeat, irregular but persistent, beating for 10 billion years. Radio astronomers have mapped the Milky Way in wavelengths invisible to human eyes, and what they have found reveals a structure far more complex than optical images suggest. The cold hydrogen gas that fills the galaxy emits radio waves at a specific frequency, 21 centimeters, and by mapping these emissions across the sky, astronomers can trace the distribution of gas through the entire disk, penetrating the dust that hides so much of the visual galaxy. These radio maps have revealed the warp of the outer disk, the positions of distant spiral arms, the flows of gas between the arms and the central regions, the high-velocity clouds of infalling material. They have shown that the Milky Way is more complex and more active than it appears in visible light, a dynamic, structured, continuously evolving system rather than the static smear of pale light visible to the naked eye. The galaxy speaks in radio. We have only recently learned to listen. The Gaia Space Telescope, launched by the European Space Agency in 2013 and still collecting data, is creating the most precise three-dimensional map of the Milky Way ever assembled. By measuring the positions and motions of nearly 2 billion individual stars with extraordinary accuracy, tracking their distances, their velocities, their brightening and dimming, Gaia is revealing the galaxy's structure in unprecedented detail. It has uncovered stellar streams from ancient galaxy mergers. It has mapped the three-dimensional warp of the disk. It has identified groupings of stars that share common origins, tracing the scattered siblings of the Sun. It has revealed the three-dimensional structure of the nearest spiral arms and provided the most accurate measurement yet of the Sun's own orbital parameters. Each data release from Gaia reshapes what we know about our home galaxy, turning a blurry portrait into a sharp one, adding details that have been hidden since the first telescope was pointed at the sky. The Milky Way is better understood today than it has ever been, and better understood tomorrow than it is today. Dark matter makes up approximately 85% of the Milky Way's total mass. This is not a small correction or a minor detail. It means that everything visible, every star, every nebula, every cloud of gas, every planet, every spacecraft ever launched, every living thing that has ever existed, accounts for only about 15% of what is actually here. The rest is dark matter, distributed throughout the halo and the disk, invisible and intangible but gravitationally real. We do not know what dark matter is. The leading candidates are particles that do not interact with light or ordinary matter except through gravity. Particles that pass through walls and planets and people as if those things were not there. Experiments deep underground, shielded from cosmic rays and background radiation, have been searching for these particles for decades without success. Dark matter has not been directly detected. It is known only by what it does to the things around it. The Milky Way holds together because of something we cannot see, something we have not identified, something that may require entirely new physics to understand. The galaxy's greatest secret is its majority ingredient. The Milky Way emits a faint glow of infrared light that is invisible to human eyes but detectable by space telescopes. This infrared glow comes from the warm dust permeating the disk, tiny grains of carbon and silicate that absorb starlight and re-radiate it at longer wavelengths, like tiny heaters scattered through the interstellar medium. When the Spitzer Space Telescope mapped the galaxy in infrared, it revealed the bar at the centre with unprecedented clarity, traced the spiral arms through the dust that blocks visible light, and mapped the positions of star-forming regions across the entire disk. The infrared Milky Way looks different from the visible Milky Way. The dust that hides so much in optical wavelengths becomes transparent, and the underlying structure of the galaxy emerges from the murk. Every instrument that observes the Milky Way in a new wavelength adds another layer to the picture, revealing features that were hidden, confirming structures that were suspected, and occasionally uncovering something entirely unexpected. The galaxy rewards careful looking. The Milky Way is turning right now, not in a way you can feel. Not in a way that makes any sound or leaves any sensation. It is simply turning, as it has been turning for 10 billion years, each part of it moving in its own orbit, the whole vast structure rotating in the silence of space. The stars near the centre complete their orbits in millions of years. The stars in the outer regions take hundreds of millions of years. The Sun, somewhere in the middle, takes about 225 million years per loop. The whole thing turns together, not like a solid wheel but like a fluid, each part at its own pace, the spiral pattern moving through it like a slow wave, and you are on it, you are part of it. You are turning with it right now, lying still, completely unaware of the motion, your body relaxed and your breathing slow, and the enormous galaxy carrying you along in perfect silence. There is nothing you need to do. The turning continues without your help. The nearest large galaxy to the Milky Way is Andromeda. It is 2.5 million light-years away. The light reaching your eye from it tonight left its source 2.5 million years ago, when your ancestors were small-brained primates walking the African savanna long before anything that could be called human thought had formed. That light has been travelling since then, crossing 2.5 million light-years of empty space, dodging around gas clouds and dark matter halos, finally arriving here, now, at this particular point in space and time, where it touches the surface of an eye that happens to be looking in the right direction on a dark, clear night. That ancient light is a message. It left before history. It arrives after everything you have ever worried about. It asks for nothing. It simply arrives. And if you are quiet enough, and the night is dark enough, you can see it with your own eyes. The Milky Way is beautiful in a way that has nothing to do with human preferences or aesthetic conventions. It is not beautiful because someone decided it should be. It is beautiful because of what it is. because of the specific way that gravity and gas and nuclear physics and billions of years of time interact to produce this particular structure. The spiral arms are a natural consequence of density waves moving through a rotating disk. The central bulge is what happens when stellar orbits align along a common axis over billions of years. The halo is what remains of ancient mergers and captured material. Everything about the galaxy's appearance follows directly from physical laws, applied to initial conditions set shortly after the Big Bang. And the result is this pale river of light across a dark sky, this turning wheel of hundreds of billions of fires, this structure so large that light takes 100,000 years to cross it, and so old that it has been here since before the Earth existed. Nobody designed it. The universe simply did what it does, following its rules, and this is what came out. You are inside it. That is perhaps the most extraordinary fact of all, not that the galaxy exists, but that something inside it is aware of it. You are not observing the Milky Way from outside. You are embedded in it, part of its mass, orbiting its centre along with everything else, made of its material, subject to its gravity. The atoms of your body are galactic material that has temporarily organised itself into a form capable of perceiving the galaxy it belongs to. The Milky Way is, in a very real sense, looking at itself through you. The universe has arranged matter into shapes that can contemplate the arrangement. That reflexive quality, that self-awareness of the cosmos through its inhabitants, is something no telescope has ever captured, because no image can contain it. It lives only here, in the mind that lies awake in the dark, and feels the scale of things pressing gently against the edges of understanding. The stars above you tonight have been burning for a long time, some of them for billions of years. They were burning when the first living things appeared in Earth's oceans. They were burning when the first eyes evolved to see light. They were burning when the first mind looked up and wondered what they were. They have burned through every civilization, every invention, every quiet night, and every loud day that has ever happened on this planet, and they will burn long after you, and everything you know has become part of the past. The stars are patient beyond any human measure. They do not hurry. They do not pause. They simply burn steadily in the dark, and the light they make crosses enormous distances and arrives here, soft and ancient, and falls on you. You are being touched right now by light that left its source before you were born. Let that settle. Let it be what it is. Something old and enormous, reaching across the dark to where you are. The Milky Way has no edge in the way a table has an edge. It fades. The disk thins. The stars become fewer and farther apart. The gas becomes more diffuse. And then there is a transition, gradual rather than sharp, from the structure of the disk to the more diffuse population of the halo, and from the halo outward into the intergalactic medium. The galaxy does not stop. It becomes something else, less concentrated, less structured, less bright, and eventually there is no meaningful boundary between where the Milky Way ends and where the larger universe begins. We live in a structure that is defined more by density than by borders. The Milky Way is not a container, it is a concentration. A place where the universe is denser and brighter and more organised than the average. And on that gradient, somewhere in the thicker part of the distribution, here we are. The night sky as seen from deep inside the Milky Way, from a planet near the galactic centre, would be nothing like the sky you see from Earth. Instead of a few thousand visible stars and a faint band of the galaxy's glow, the view from the central bulge would show millions of stars to the naked eye, an overpowering blaze of light in every direction, no true darkness anywhere. The concept of a dark night would have no meaning. Astronomers studying planets in such regions sometimes wonder whether complex life could arise in an environment so different from the quiet darkness of Earth's nights. Whether the constant light would be a comfort or an obstacle, whether something living there would look outward toward the sparse edges of the galaxy with the same wonder that we look inward toward the dense bright centre. Perspective is everything. The view depends entirely on where you stand. Right now, several dozen people on Earth are looking at the Milky Way through telescopes. Radio astronomers are collecting signals from pulsars and hydrogen clouds. Infrared astronomers are mapping star-forming regions. X-ray telescopes in orbit are monitoring the central black hole for signs of activity. Graduate students are analysing data and writing code and arguing about the implications of small discrepancies between models and observations. The work of understanding the galaxy is continuous. It does not stop at night. In observatories on high mountains and in control rooms connected to telescopes in space, people are gathering information about the galaxy, one measurement at a time, slowly expanding the boundary of what is known. The galaxy is not just being observed, it is being understood. Piece by careful piece, the picture sharpens, and every new detail revealed opens more questions than it closes. The Milky Way is deeper than the deepest measurement ever taken of it. Your atoms have a longer history than you do. Every atom in your body has existed since shortly after the Big Bang. Hydrogen atoms formed in the first few minutes, heavier atoms forged in stellar cores over billions of years. These atoms have been part of stars that no longer exist. They have been part of interstellar gas clouds that drifted for millions of years between the spiral arms. They have been part of the accretion disk around a newly forming sun, incorporated into rocks and oceans and living things, and the continuous recycling of matter that defines life on Earth. And now, temporarily, they are part of you. They carry no memory of their history. They are simply atoms doing what atoms do. But the history is real. Your old material in a temporary arrangement, and the arrangement is resting now. And the old material continues being what it has always been. Patient, ancient, part of something larger than any single thing it has ever been part of. The Milky Way is not going anywhere in particular. It is moving. Everything moves, but there is no destination. There is no edge to arrive at. The motion is simply what is. And from inside it, on a quiet night, with the body at rest and the mind drifting, the motion is completely unfelt. The galaxy travels through space in perfect silence, carrying everything within it, every star, every planet, every sleeping thing, and none of them feel the journey. That is perhaps the deepest rest the universe offers, to be in motion and not feel it, to be carried and not know it, to arrive somewhere new with each passing second and feel only stillness. The galaxy moves, you rest inside it. Both things are true at the same time, and tonight that is more than enough. The stars do not disappear when you close your eyes. They continue burning. They continue moving in their orbits. The spiral arms continue their slow rotation. The central black hole continues its patient waiting. The interstellar medium continues its turbulent drifting. The stellar nurseries continue their slow collapses, building the next generation of suns. The galaxy does not pause because you are not watching. It does not require witnesses. It simply continues, as it has continued for 10 billion years, with or without observation, with or without understanding, with or without any arrangement of matter conscious enough to wonder about it. Tonight it continues, and you can rest inside that continuity. The galaxy will still be there when you wake. Whatever remains of your thoughts right now, let it drift. The way a star drifts slowly outward along the spiral arm, the way light drifts across 2.5 million light years from Andromeda toward a dark adapted eye. the way gas drifts through the interstellar medium for millions of years before gravity gathers it into something new. Drifting is not stopping. Drifting is still moving, still going somewhere, just more gently than before. Let your thoughts do that. Let them slow. Let the sentences grow shorter. Let the distances between ideas grow longer. The galaxy is still out there. The stars are still burning. You do not need to hold any of it right now. It holds itself. It has always held itself. It'll hold itself tonight. The Milky Way is enormous, and you are inside it. And both of those things are true right now. Enormous, inside, still, turning, dark, full of light you cannot see, full of things still becoming, the stars burning without noise, the gas drifting without direction, the dark matter holding everything together without showing itself. You breathing, the galaxy turning, both continuing. Neither in a hurry, neither asking anything of the other. Rest now. The Milky Way turns, and tomorrow night there is a universe beyond even this, stranger and more full of wonder than any one night can hold. We will go there together,